I just realized that I was muted while I was talking, so there's that. So yeah, I was saying that today I want to continue working on the project from yesterday, which is the code generation Hawaii project to generate type-safe clients, F# clients from OpenAPI documents and generate nice type-safe F# code from it. I was pretty much hyped to get going with it because I was a little bit fighting the urge to not do anything off screen because I want to do as much as possible live so that you could see that process and see how that goes. So yeah, I said, why not? Let's just do another stream while I'm at it. So yeah, I think today we'll be focusing more on code and not so much jumping back and forth between random code on GitHub, hopefully. So let's get started with that. Let's make sure everything is working. Twitch looks all right. Let me open up the project. You can find it online, of course, on my GitHub, also named Hawaii. This is the project. By the way, I started publishing my streams on YouTube. So even if you miss them on Twitch, I will be editing them a little bit and then publishing them to YouTube. And for this project, I'll be publishing all the videos on this playlist, the F# Hawaii playlist, which sounds a bit weird if you don't know what this is about. Anyways, let's get into it. Yeah, it looks like I did some stuff off screen, and I did say git stash. Yeah, so basically this is the code that we left off from yesterday, and yeah, it's basically a console application in F#, which reads the information from this schema and generates a project called pet store. And for now we only generate the global types, the types from the schema. Let's look at the schema again. This is basically a Swagger schema, an OpenAPI schema, which has everything we need to know. So I'm gonna go JSON viewer, copy, paste this in. So yeah, this is the JSON schema we're working with, and we're looking, yesterday we were looking at the definitions, the API response, the category, the pet, etc., and how we can generate F# records from them. Of course, the types can be pretty advanced. So here, for example, we have object and these three things, and each of one could be another type, of course. But we will get into more advanced things like, for example, when we have references. So a pet can have a property called tags, which is an array where each item is of type tag, which is another type, a reference to another type in the definitions here. So we need to take care of that, so that the generated type for tags is an optional list of tags, or array of tags, whatever you want to call it, but basically it's an array of a referenced type. So you need to work around references. Something else we will need to work around is, well, at least implement, is the enum strings. So for example, status here is not just a string, it's also an enum, which can be one of these three things. I'd also like to tackle this in this stream. Another thing that we can add easily is the descriptions, as in the form of comments for the code. So let me show you how far we were the other day. .NET Run. And .NET Run will get the stream from the schema. It will basically make an HTTP request to get the schema, make an instance of the OpenAPI reader. We get an OpenAPI document from the reader, and from the properties, from each property in the schema, from each schema and the components, which are these definitions here. These definitions correspond to components schemas, which is a key value pair of a string, the name of the definition, and the types, the schema of that definition. And from each one of those, we're creating a record. Now, I'm not sure if we are going to encounter things that don't look like records. I think they're all records, but I'm interested to see what kind of edge cases exist in here. But now we haven't gone that far yet. So what we have here is the initial implementation, which creates a recursive namespace, which is important when we want to reference other types in the same module. It makes, from each definition, it will create an F# type, an F# record from it. And it also accounts for optionalness, in here. What it does not account for is, right now these types aren't entirely correct, because what we're doing is we're matching against a couple of types and then defaulting to string otherwise when we don't know, which is incorrect because there are many other types that we didn't account for. So this is what I want to do. I want to extend this function, which implements the types for the properties. It tells me which property is required. What's the property name? I'm not sure if we're going to use that. And the property schema. This is the property type. The property schema. So I think I will start calling things with better names. Otherwise everything will just look like a schema and we don't know what is what. So this is working alright-ish. What I don't like about this implementation is that we have something says if required, then we have the type, otherwise it becomes optional using the option type. So I don't want to apply this condition and checking on each branch. I want to automatically apply that for each branch, even when I add ones. Okay, so let me do that. I'm not sure if anyone is in here. Yeah, if there's anything wrong with the sound, if you have questions, just let me know like always. For now, I want to make, just to tidy up things. So what I did, and I reverted it back, is that I put these functions into their specific files, into CodeGen and extensions. Extensions is for this extension, which allows me to create a record from a string and a type. Yeah, so we have these extensions that I put in here. Just move them around. I don't think I want to use this yet, so I'm just gonna delete it for now. Okay, so I moved those into extensions. Let me add that to the project. If you're using Visual Studio, of course, you wouldn't need to do this. Extensions fs. Because Visual Studio, you could just add the file and it will automatically be added. So we have extensions. We also have CodeGen, which I refactored a bunch of functionality. So I could basically remove this in here. I'm just tidying up the project. I don't need this one. Don't need this one. I think this one is just a little bit too high. Okay, now I can focus better. Okay, so I moved all these functions to create the namespace, the qualified module, the file, the formatting, all to the CodeGen module. And now my code doesn't run anymore, rightfully so, because the CodeGen module isn't added to the project. So I'm going to add it in here. Compile, include CodeGen fs, and it should be added. And now I could say CodeGen and CodeGen. Okay, that sounds like about it. So let's build, make sure everything's working. A little bit of tidying up. Right. Everything seems to work. Let's just run it, see the results one last time. Okay, that's great. Object reference not set to, okay, property schema. Where is schema coming from? Ah, it's coming from this schema. I'm pretty sure it's about this, which is a good reason to put this out of here into a specific function so that we know what it's using and what it has access to. So now it has become a standalone function basically. Let's see, yeah, it doesn't have anything required and we are just calling it into here. So for each property in the schema we create the type for it. Yeah, it's good that we try to run the thing. Yeah, it's working okay-ish. So let me try to improve this function. So we have cases that handle integers, we have cases that handle long, integer, and array. Let's clean up this option type. So what I'm gonna do is, since it is only dependent on this required property and we only need it for the top level property type, whether it's required or not, I'm going to do this. So if required, then we will calculate. If required, well, if not required, we want optional, right? If not required, we say optional type is the calculated type from the function called recursively, where it's no longer required. So if it's not required, yeah, so only the top level will be optional or not, but anything else called afterwards will be required. So we won't be having like option of list. It will always be option of list or option of integer or option of string, things like that. So we only apply it at the top level of the optionalness is only applied on the top level, and everything underneath will be optional, will be required, sorry. That's why required is true in the recursive call. So the optional type will be create this. The property name is just propagated. The property name is propagated. The schema is also propagated. And what we return here is syntype option of this optional type that was calculated. Else start matching the exact types. So what is this option type, syntype? Yeah, this is a sin type, right? Why is it not happy? Because if not required, is it something that has to do with inference? Because I'm calling it before it knows what it should return. So basically, if not required, it means it's optional, in which case we calculate the inner type using the same function, where required will be true, and then we pass it into option. Otherwise, all these things won't need to check for optionalness. Instead, it will be just like this. So that cleans it up. So the next time we have an optional int64, first the int64 will be calculated and it will be propagated into the option here. Same with array, we don't care about we don't check about required, we just do it once. And that makes the code somewhat more cleaner, easier to see what's going on. I hope, I think. Let's just sanity check. Of course, we know here from hi there, null reference achievement unlocked. Oh, I have this achievement unlocked almost every time I use F#. Don't worry about that. Get them while I still can. Null reference here yet? Yes, absolutely. If you're using C# APIs, you better expect some null reference exceptions. But we hope we won't get those anymore. With a big quotations on the hope. But let's see how it goes. So, optionalness. Everything has become optional. Everything has become optional. Is that correct? So let's look at the pet. Let's look at the pet, because if you look at the pet definition, we will see. I think that's correct. It's just that this is how the type looks like. We have the pet, and pet has properties where only name is required and photo URLs are required. That's where these two come from. Only name and photo URLs. So only these two won't be optional. And that's exactly the case. Name and photo URLs are list of strings, and string unless everything else is option list of string. Okay. So we took care of the optionalness. All right. Let's handle more types. So Boolean will be interesting. I don't think it has a format, so it will be just sin type bool. What else? So I saw some interesting things with the string type. So you could have a string type when the format property schema, when the format is a unique identifier, UUID. I think it was like this. I think it was this case. In that case, we want to generate a GUID. Same type GUID, please. No. Create unit. Create long ident dictionary. Okay, I definitely want the GUID. It's probably something like create long ident, which takes a string. I'm pretty sure it had overloads. Let's see. So it's okay. A long ident with dots. That's the ID, or otherwise a string. I would want to use a string system.guid, but Fantomas will think that's actually the type name, and it will make it into system GUID, which is not what I want. I want the fully qualified type name. So instead, I'll just create what it wants. It wants a no. Let me look at the other overload, please. Yeah, long ident with dots. It's this thing it wants, and I can create one. Create from a list of strings, and I think I should go system good. I think that's how it went for generating a GUID. I'm not sure the schema has those here. Let's walk through some of them. So we have tags. Tags have name and yeah, just this. Order, properties, ID. No, still long. Pet ID, quantity, ship date. Okay. This is another interesting one. So it wants a DateTime format. Status, it's an enum. Okay. Complete is of type boolean. So I think at least we get the boolean here right. I'm not sure about this one. Let's get the DateTime one right. So property schema. Format is DateTime, which will be syn type DateTime offset, because you want that offset. Okay, let's run it. See how far we are. Okay, ship date is an option of system DateTime offset. That is correct. Let's look if we have anywhere we have a GUID. We don't, but that's all right. I mean, we got the ship date, the complete, which is an optional boolean. Again, I don't know why boolean is optional here. You would think that it's required, right? I would think it's required. Ship date is this format, which turns it into a DateTime offset. So that's cool. And this will be an optional int64. Yeah. Yeah, the rest look good. So now I think it's time to tackle the unions, because those are interesting. Even though they are not their own specific definitions in here, I think we want to generate specific union cases from them. So when you have a pet and you have status, we might want to generate something that is called pet status, or just status. Maybe we'll have to do something about type name resolution if there are type name collisions, which is something I also had to deal with in Snowflake with GraphQL. But this is the idea. So before that, example doggy. Okay. Before that, let's see if we can get the description as a documentation for the property, because this is the status property, which is currently being converted to an option of a string. Let me try if I can get the description as a documentation here. So where are we generating? Okay, so this is where we're generating the field. I think we can say let field is this, and this is how we return it, but we don't just want to return it, we want to update it. Update field with the pre-XML doc will be, let's hope that it has a pre-XML doc. Is this thing empty? Just okay, it doesn't have that. That's very interesting. I would like to navigate to this type. That's a bit unfortunate that I can't. Maybe just XML doc? Oh, that's nice. So the XML doc will be create, and create will take a string of the description. So schema, now I'm taking the property schema, a property type dot description. If you have to do the same thing we did before. Okay, let's see how this goes. I think even if you have empty documentation, it will just make empty slashes, but I don't want to see any empty slashes if there are no docs. So we don't want to create a list of description unless it actually has a value. So if string is not null or white space, yeah, if it's not null or empty, then return it. Okay, just say docs, nope, docs equal this thing. Okay, that looks alright-ish. .NET run. I'm still not very happy about how many things are optional in here. Okay, we are getting something. We are getting user status, order status, although they're not very useful. Pet status in the store. Yep, we're getting there. We're getting something. Okay, that's really cool. So these are the docs from the fields. What else? Yeah, the enums. Let's tackle the enums. Let's see. Okay, so I'm not sure. Here's the thing I'm thinking about. I'm thinking about the following approach. If we know that we're looking at the top level definitions, and the top level definitions might have enums in here. I'm not sure if you can define an enum on its own. So here I'm assuming these top level definitions are objects. Let me just skip those that aren't objects. So if these top level definitions, if schema value dot type only when the top level then just like this, only when the top level schema types are objects, then because if you have a top level enum, then we have to do something else about this. In which case, okay, so this creates a send module declaration. But if you had an enum, as a top level type, then we should generate a union case. However, I still want to generate union case from things like the status, which is something I could also search for in the schema, but my concern is that status could be like an object itself, which has enum underneath, which might be hard to find in here. So what I could do is actually recursively search all objects for enum definitions and output enums from them. I'm getting a little bit ahead of myself here, but this is what I'm thinking about. But we are getting somewhere. We're making some nice types here. Because it's funny, we are generating a record, and at some point in here we figure out, oh, we actually not only need records, but we also need some more types, more types that are referenced from this record definition. Okay, so what I'm gonna do is find the enum types and add them to the modules. Let's say recursive find enum types, which takes a schema, which takes an OpenAPI schema. In this case, I'll leave it as schema because I don't know how deep the search will be. Okay, so if the schema is a... Do we have something called isEnum? Enum? This is also interesting. The enum is a list of any. Oh boy, we're getting into untyped territory. Let's hope OpenAPI doesn't go all too crazy with those. Alright, if I assume that enums are strings, I'll assume enums are strings. So if enum is not empty, count is more than 1. Should I also check whether enum is not null? Not is null, because who knows what the C# API does. And schema, then we have an enum on our hands. Find enum types, but we don't know the name from it, because the name comes from the object property. Okay, I'm getting way ahead of myself here. What do you think? Not entirely sure how to tackle this. So I could start by figuring out the top level enum types, or the deeply nested enum types, but that won't be enough. So I also need the enum name, which is a string option, because at first I don't know what type it will be. If I have this, then I want to generate a list of a tuple if not is an enum count. Okay, I basically want to generate a tuple of enum name and match enum name, a tuple of the enum name and its cases and its possible cases. Basically, I want a give me a string times string list. That's one enum. list. Let's say enum name times enum case list, which are both strings in this case. If I can get that, I could generate those into, I could generate and add those into the global types. So let's see how we do that. Match string enum with some name, and I will generate a list of a single tuple. And I need to get the list from here. So this is the name, enum name. These are the cases. Will be schema enum select. Why am I using select? Because you can. Fun enum goes to enum dot any type. Oh, the any type, and then what? To string maybe? Okay, I'm not happy about this. The select. Let's go. Sequence map fun enum case dot write to a writer. That's not what we want. It's the any type. You know what? I'll just go to string and hope that I can get the actual string from underneath. Cases. Yeah. If I don't have an enum name, then I'm out of luck. Okay. String option. It is not happy because it thinks I'm returning a unit, but now it is happy. Does this make sense? I'm trying to... So this is my base case after I found some enum type, but if I haven't found an enum type, I should, which means I am into an object or into another schema type in which I have to recursively search down. And when I found something that is interesting, I need to return it. I'm returning a list because here we will call the same function multiple times. I think we will do it like so. Else. So this is when schema is an actual enum. I'm assuming to string will give me something interesting, but let's see for it. So otherwise I don't know what schema does. So for property in schema properties, do if so property could be something like this, right? For each property we will have status will be the enum name, and then the enum cases will be here. Okay, for each property in these properties, if not, can I do this? property name and property schema. Hey, I can do that, that's cool. Oh, I cannot. Nope, I cannot do that. Okay. Property. Let's property name will be the key from this pair, and property schema will be the value of the pair. Now I have the property schema, which is the potential enum. I could say yield, and instead of this empty array, yield find enum types, where the name of the enum will be a potentially some property name, and the schema I'm looking at will be this one. This looks okay-ish, I'm not sure about it yet. But you know what, we could just call it and see what happens. So actually, I mean, call it, debug it. So let enums will be enum types, or enum definitions will be the following. So for each schema, we will try to find the enum types, where initially we don't know the name, and the schema value will be the top level type we're looking at. Okay, I hope that makes sense. Let's see what the debugger tells us. Debug default project. So yeah, this returns a list of the union definitions, which is name and list of cases. Okay. All right. And enum definitions, there are 6 of them. Let's see. Raw view. This is not very helpful. List dictionary internal. This is not what I was looking for. Enum definitions is supposed to be a list . So this one has length 1, this one has length. Okay, let me look at the one that has length 1, because that's the one that is interesting. Yeah, this one has status, with the second item of the tuple being OpenAPI string, OpenAPI string, OpenAPI string. That's not what we want. We want the, okay, so we found the status. And what else? I think it's the order status now. Yeah, this is a different status, I believe. Okay, I'm digging too much into this, so what I will do is continue. Let me filter out the ones that are empty, so match the with empty, then, well, empty. Yield empty. Types yield enum types. that's exactly the same as if I did this. So no, that's not how I would filter them. Yeah, I think the filter happens here. Match with well, for each enum name, enum cases in the found enum types, if the enum cases are not empty, enum cases will be a sequence. Okay, so if sequence is empty, of course I mean not is empty, then return this tuple, something like that. So now I don't get empty enum definitions, but still we need to fix the fact that enum case to string doesn't give me anything of interest. So enum case any type to string. I hope that doesn't give me just any type to string. Let's look at it again. So I'll put a breakpoint here, debug the F# code. Everybody following along? Let's see how far we can get. All right, enum definitions. For now, only 2 of them. And the first one is a tuple, where status and this one. The other one is also called status, but these two come from different types. One comes from the pet status and one comes from the order status. Am I right? Let's see, properties status, which is coming from the pet, and the other one is the order status. Let me look at the second value. Results view. Primitive, primitive, primitive. Yeah, so these are the types of my any types. I think I will have to do some kind of abstract matching. What do you call it? I don't know what you call it exactly, but I need to do some type pattern matching where it seems that the any type could be an abstract type of different types, namely the primitive ones, and the primitive ones will have a value. So let me try to extract that. For now, I'm thinking I'm on the right path. I'm thinking I'm on the right path where I'm just not finding the right type names. So let me just. So let's make sure we get nice names from the type. So instead of just property name, we also take the parent name. The parent name will be passed in here. And when we start schema, type name will be the schema value, schema key, because these are the top level definitions again. So the type name will be the parent name. Okay, now we get a parent name, which we combine here. parent name plus property name. So now we will get pet status and order status. Of course, I need to capitalize the property name. To do that, I will cheat a little bit. I said I won't be cheating, but just a small bit that I can copy paste from my code here. Capitalize, there you go. That's a lot easier. Capitalize. So capitalize will be applied here. Assuming parent name, which is the top level type, will be capitalized. Alright, so far so good. Of course I would need to actually create enums from those, but I'm just making sure that I'm on the right path. So any type is of type I OpenAPI any, which is abstract. Okay, it's an abstract property. Alright, I think I'll need to do some pattern matching here. Match enum case type with primitive type, whatever that is, as primitive value. If it won't know about it, but hopefully this one can tell me. Any type does not have a proper subtype and cannot be used as a source of type test for runtime coercion. Okay, is it the enum case that can do that? Complete pattern. Okay, it isn't finding primitive. I OpenAPI any. Readers, yeah, this one. Models dot. It's not finding anything because these are not the modules here. OpenAPI any, okay. There are interfaces. Maybe there's something in here that is interesting. And there's also the any namespace, which is also interesting. Okay, let me use that and see how that goes. So any. All right. OpenAPI string. Hey, that's something. Value. Except that I don't have a default match case. So I need to map to something. Instead of map, I can choose things to map. So this returns some, and all other cases will return none. All right, let's give that a try. We got the primitive names. I think this will work, I'm not sure. And the enum definitions. So let's see what that gives us so that we can quickly create the enum types and see what we can do from here. Okay. Debug F# project. Okay. Enum definitions, I got 2 of them. The first one has pet status. Okay, that's more like it. That's more of the type we want to generate. Item results view. Hey, that's nice. available pending sold. What else? What else? This is quite nice. What else? So this is the first one. The other one will be the order status. Order status. And the second item, results view, placed, approved, delivered. Awesome. That is more like it. Okay, so now it's time to create F# types from those, because we have the definitions, nice and filtered. I want to add them to the global types here, so that maybe the record definitions can reference them from the same module, because this is a recursive module that we're generating, so it can reference types in the same module. Okay, so far so good. Terminal, yeah, user status still integer, so we're dealing with the order status, and we're dealing with the not the tags yet, but the pet status here. So here I want to have an option of pet status, and here I want to have an option of order status. So that's pretty much the idea. Okay, we have the definitions. Let's look how to generate F# code from it. And I forgot how the API looked like. So what I'm going to do is, yeah, these are some helper functions to normalize the names, which we will need to do. But for now, I just want to create an enum type like this. So let's see how we can do that here. Create an enum type. It takes a string times a sequence of strings. Create string enum, we will add it later. Of course, we will add require qualified module. Enum type first of the enum type, not the fifth of the enum type, it's the first of the enum type. We don't have a description because we're basically coming up with a type on the fly. It's not part of the definition. So this is empty. And now the values will be those. In GraphQL, I did some filtering for deprecation, but I don't think we will need that. So instead, values will be just SND of the enum type, which will give me the second element of the tuple. All right. Yeah, there's also something that has to do with the compiled name attribute that I need to do later, but for now I just want to see the types generated in the module. Hey, why I cannot do this? Yeah, it is not CSS or C#. I don't have docs again because these are ad hoc functions, ad hoc types. And I don't know how to normalize the names, so I will just capitalize those. No, I'm just gonna use them. Value. Everything else doesn't need to change. Enum representation, and finally we get a syn module declaration. Okay. So enum definitions, let enum types will be enum definitions a list map to create enum type, and once we have that, we can yield those here. And now we should have something interesting. the next step we will have records that reference those ad hoc enum types. But for now, it looks like we have some enums. Of course, these are not proper enums because they have to be uppercased. But even though they're uppercase, we don't want to lose their casing. So this is where the string enum comes from. They're lowercase here, but we don't want to lose their casing. Okay. So I'm just gonna put back some things. Yeah, I need this one, create attribute list, and needs an array of those things. Sin attribute. Sin attribute create. What does this take? Only a string. No, I want not just a string, I want the entire thing. Which again, I had it in here because it was easy to do it like this. Create compiled name. Oh, it was just this, okay. Compiled name. So the compiled name is what we will use here. Compiled name value. But the actual case will be capitalized, so capitalize the value so we don't lose the casing. Now I should get something that actually compiles. I'm not going to actually compile it here, but the code should look like it will compile if I was compiling. Hey! Now that is cool, isn't it? Pet status, available, pending, and sold. Order status, placed, approved, and delivered. We use the compiled name for serialization and deserialization, but when we are using these types in the code, we go order status dot, and then we get all the types, all the possibilities, and we get them in here. So that is really cool. I'm really happy with this. One final thing I want to do is, of course, well, in Snowflake I had like a whole normalization functionality for the enum values to make them nicer. I'm just going to assume that the values are good enough when just capitalizing them. Okay. What I want to do is finally being able to reference the fields in here. I want to be able to reference the fields which will use the create F# type, and I think now we'll be using the property name. So if the property name is status, I'll also be needing the parent type, which is the record name here. Okay, I guess more information. Record name will be added to the create F# type. Record name. And I'm just going to pass that down. Okay, we resolved backward compatibility. I just need to make use of record names. So when the property, so here we have to check if we're dealing with an enum, in which case string when, so this is a string when we're dealing with an enum, and we know we're dealing with an enum if this holds. String when we're dealing with an enum, except that we're not looking at the schema, but we're looking at the property schema. Then I need to reference the type that I created earlier. I don't have access to it here, but I have access to the record name and the property name, and I just have to capitalize those together. So it will be sin type create. It takes a string. So that means a record name plus capitalize record name, capitalize property name, where capitalized needs to be defined first. I hope this makes sense. If you have questions, just let me know. I think I got it. So string when not is null and has actual values, then we are dealing with an enum, which we assume is defined because we defined it earlier in here. We are yielding the enum types first, which means we can reference those when creating the objects here, which is kind of cool. So, moment of truth, .NET run. And I guess we have something, because look at this goodness. Status has option of order status, and order status is defined here. How cool is that? We were able to come up with an ad hoc type. How cool is that? What about the pet? The status of the pet has option of type pet status, and it just works. It just works. These are the global types of the schema. I'm really happy with this. What else we need to handle? We've handled, yeah, I think this needs more extending. Of course, I think I haven't dealt with numbers such as floats and decimals. Yeah, I think I have to do something about the DateTime format, because that's something that they provide. But for now, I'm pretty happy with the results. It looks pretty cool that that we can do this. As you can see, I was thinking, like, through the day, I was thinking about how the implementation would look like. And I didn't want to wait a lot before I started implementing this feature. I was really hyped to see if it would actually work, and there we have it. We have an actual prototype of the global types. Of course, this is a long way to go from a full-fledged implementation, because we still need the client to implement the client, which goes through the paths and creates operations from each of those. So this is the upload file. Yeah, I have to figure out how uploading files should work. I need to figure out when something has to go in the path or in the body, so things like that. Yeah, so here, for example, the pet ID is required, and I think there's somewhere that says, yeah, this parameter goes into the path. So there are parameters that go into the path or the body or the query string parameters. I think some other parameters go into the headers, but I'm not sure. So this one requires an API key. Alright, these are problems for later. I'm getting way ahead of myself, but I'm really happy with what we did here. I think I'm gonna leave this to do here for a while, because it will take a while before all these edge cases have been dealt with. So I see no questions. I'm happy with the results, which means for today I'm going to wrap it up again. Thank you all for watching. Let me just include all these great changes. Just patting myself on the back a little bit. Let's implement enum code gen and referencing the types and referencing the cases and referencing the enums from object properties second string. All right, super cool. It means that I'll also be publishing this on YouTube. So if you couldn't catch up to it, you will see it added into this playlist here. And with that, thank you very much. I hope you enjoyed this. Hope you also like the results we got in here, and hope to see you next time. Bye bye.